Hi. Hi, everyone. Today is Friday. Friday is my happy day. And when I'm happy, I like to sing about chemistry. This is my song about chemistry. Would you share if I asked you to share? Or would you take what I have to give? Would you pull off my valence electron and be my charge tonight? 'Cause I can be your ion, baby. You can take away my E. And that's because you've got a higher electronegativity. Have a wonderful Friday, everybody.
To another fabulous Friday Funday. I am your host, Mrs. Zygnerski, and welcome to my kitchen. In today's episode, it's all about time. About time what? No, it's all about time. Or clocks. Or iodine clocks. Yes! What am I talking about? Well, in this episode, I'm just going to let you guys know, I'm going to go over a little bit about reactions and reaction times, reaction rates. In other words, something called kinetics. If you're one of my AP dudes, you're probably kind of sort of shuddering right now at the name of kinetics. But what kinetics is about the rate of reactions. And just so that you know, every reaction takes a certain amount of time. If you ever noticed in some of our previous videos, some of them seem to happen instantaneously. Others may take a while to happen. If you think about it, it takes a while for somebody to grow. We're all having chemical reactions when we're growing, when our hair grows, or when rust is formed on a nail. That takes time. All right. So with this one, it's called the iodine clock reaction. And I have things out here right now, everything that you need for it. Now, before I even start, safety first, I'm gonna put on my goggles, because you know it's gotta be good when I gotta put on my goggles. And I'm gonna put on my gloves. Now, I wanna give credit where credit is due. I found how you could do this one at home from a video from a science dude called the Bearded Science Guy. And I'm not talking about Mr. Talish, just saying. So, anyway, shout out to Mr. Talish. All right, so I cracked myself up on that one. All right, so what we're going to need, we're going to make two separate solutions, and then we're going to pour it into one. So things that we need: vitamin C. All right, so we're going to take a couple of vitamin C tablets, or at least one of them, and what you're going to do is just crush them up. Now, if you don't happen to have a mortar and pestle, it's okay. I mean, some people do have them in their kitchen. It's vitamin C. It's going to be okay if you actually crush it up. All right. But if you don't, you could always use the back of a spoon or anything like that to just kind of get it all crushed up. All right. And then I transferred it into my little fleeker. Isn't that cute? A little fleeker. It has a little handle already to give it. Okay, I digress. So with that, you're going to put in some warm water. All right, so around 128 milliliters. I know, such a nice round number. I'm going to take just my little stick because for these kind of things, I'd rather have something that's going to be disposable. All right, so the more dissolved your ingredients are, the better. All right, because it's not going to react as quickly as you would like if it's not readily available. All right, so I'm just going to stir that up. I'm going to let that sit. I kind of see some particles, but I'm guessing that the ascorbic acid, which is vitamin C, is actually in the solution. What you may see around there is something called the binders, all the other things that hold the tablet together. All right, then what I'm also then going to stir in is around 12 mils of the iodine solution. Now be careful when it comes to this. If you got a cut, it'll burn. And then when I say burn, you'll feel like, oh my goodness, it definitely is. I definitely have a cut. But anyway, the other thing too is that it does stain. So another reason why I got my gloves on. All right. All right, so that is all ready. That is solution A. Notice how I have things labeled, because good chemistry practices is that good lab practices is to have everything labeled. For solution B, we need about 40 mils of boiling water. So hopefully this is definitely hot enough. And we need about 200 milligrams of starch, which, I don't have a balance at home, believe it or not. With all the things I have, you'd think I would, but nope. So anyway, I'm gonna do our best to dissolve this. All right. So the reason we need starch, if you guys remember when you were in biology, in bio classes, they do a starch test. And what I have here is some of the iodine and the peroxide. And I have a potato chip, so we're going to see what happens over time. I have marshmallows, so let's see what happens with that guy. Carrot, let's see if that has any. This is shredded coconut. It's being sacrificed in the name of science. Some dried pasta. What this is just hair from corn, because I just took some pieces from corn. Why not? I just didn't know. There's the corn kernels. It was also an old piece of corn that I was like, oh, before I put it into compost. There it is. This is the leaf, or whatever you want to call it, what you shuck. Apple. And this is why I got my gloves on, because I don't want to stain my hands. Maybe that's the way to go. So the way you know if it's got starch in it is that it doesn't have the typical iodine color, but it turns that blue. And I think that guy should have, right? Marshmallows. Who would have thought marshmallows turn blue? No, the reason the marshmallows turn blue, guys, I know that was like obnoxious the way I just talked, but it's because they do have cornstarch in it. And by the way, just to test it out. All right, let's see. Cornstarch. Definitely dark blue. So the hair didn't on the. I wonder for the corn, if it didn't, even though there's cornstarch, I wonder if these are just too dried up, that it doesn't do it. I wonder if you gotta mush it. Sad day. But that's okay if things fail. That's why we do science and experiment. Now fun little side experiment to do at home. I do believe you had to do the starch indicating reactions with different foods and potatoes and whatnot. And so you knew something had starch in it because it turned this blue color when it was in there, when the iodine got in contact with the starch. And that's because when you had this iodine ion, okay, that means iodine is not with its twin. It's diatomic as an elemental molecule, but it's by itself, so it has a negative ion. It means it has an extra electron that's attached to it. And when that negative iodine ion gets into it, it actually turns the starches blue. So what do you think this reaction is going to look like? How do you know it's going to be to what we call completion? Well, the one thing I want to tell you is that now that I added the peroxide into this starch solution, this is what's going to activate the iodine to become an ion. And that way, we're going to be able to see what the reaction is. All right, so we'll pour this together. Notice it didn't happen right away. Remember I said this reaction is all about time. So I'm going to pour this in again. When does this reaction occur? When it occurs. That's all I'm going to say. If I had exact measurements, I could actually calculate about when this reaction is going to occur. Oh, ready? I think it's going to start going. Because I see that it's starting to discolor a little bit. And it's slowly, abracadabra, here we go, and poof. Oh, I love my subject. How can we get this back? I don't think we can. As far as I know, it's a one-way reaction. So, what happened to this reaction? I'll tell you, but you know what? I'm gonna first take these goggles off. And now, what about the gloves? Oh, pardon me as I take them off. Magic. All right, so what is going on? Well, I mentioned this is all about kinetics. Kinetics is about the rate of reaction. Rates of reaction are a constant, but only in that moment. Sure, whatever you say, Mrs. Z. It makes sense. What's going on during these reactions are two of them at the same time. First, we need to understand, when it comes to elemental iodine, I2, when it comes into contact with starch, you know there's elemental iodine because it turns blue, that ink blue. All right. Then there's the ion form, the iodide ion, I negative. It's negative because it took electrons from somewhere else. When it comes in contact with starch, it's actually colorless. So, there are two reactions happening. So with the iodine and the vitamin C, it's a very fast reaction that is happening with the iodine and the vitamin C, the ascorbic acid. What happens is that it makes this into the iodide ion and it's colorless. So it's making it into these ions. Then it's becoming the ions and it's producing more of it into this slow reaction. The iodide is reacting not with the starch, but it's reacting with the hydrogen peroxide. With that hydrogen peroxide, it's making the elemental iodine and it's then also becoming water, because peroxide, it's a little unstable and it just goes H2O2, becomes H2O and O2. So anyway, once it becomes that iodide, it has that telltale blue. Now notice it took a lot of time for it to happen, for that reaction to happen, to become eventually blue. And as I mentioned, it's whenever there was iodine that was coming in contact with the vitamin C, it was becoming colorless, and it happens really rapidly. But then after a while, the vitamin C is all taken up, right? So it's all gone, it's consumed. So then it still has an excess of hydrogen peroxide. And so that peroxide is reacting with the iodide ion. And then eventually it becomes just that elemental iodine and water, and it becomes blue. Clear? I bet you it's as clear as this solution. Not supposed to happen right away, but do you see how it just turned yellow?
Okay.
Okay. That's all I have for today. I hope you guys do try this at home. It can be a little expensive, I'm just going to let you guys know, but it's really fun to experiment, to see what could change, to see also how quickly you can make that reaction happen, or how slowly you can make it happen. Until next time, never mind. Make it a wonderful day. Bye. Isn't it ionic? Don't you think? A little too ionic. And yeah, I really do think. So first, take these goggles off. Pardon me as I take them off. The magic of television!